All right, ladies and gentlemen, we're finally getting down to the nuts and bolts of what makes physics physics. Now, if I were to ask you guys what physics means to you, we've got a lot of buzzwords that pop up. We've got motion, energy, interactions, matter, gravity, things like that. Specifically in this first unit, we are going to be looking at one-dimensional motion. And we started with a lab between looking at the difference between distance and displacement. And those are a couple of our first few properties. We had a great live session this morning. And one of the things I asked you guys to do before we hopped in there is take a look at a warm-up I set up for you guys. Is water wet was one of the questions. Right? And looking through at your responses on the discussion board, we had a lot of great thoughts. There's a couple different sides of the argument, how you could prove each side, who do we think is right, and the short answer is that there is no right answer. And that's because motion is relative. Physics is relative. You might have heard of Einstein's theory of relativity, and that's way, way down the road as far as we're concerned in physics. But we still need to keep in mind that all motion is relative to something. The first thing we want to tackle is looking at vectors and scalars and identify the differences between each one. A vector is going to have both magnitude and direction, whereas a scalar quantity is just going to have magnitude. So some examples of vectors that we'll have are displacement, velocity, acceleration, momentum, and force. Scalars, some examples there would be distance, speed, time, mass, and energy. The most relatable one we have so far is distance versus displacement. Right? We're saying that vectors have both magnitude and size and direction. Okay, and we saw that in displacement. That was essentially the net of our trip in each of the parts of the lab we saw earlier. Whereas the scalar quantity distance was essentially a total of all the steps that we took throughout that course of movement. Sort of another example I might show you here. If we have these 2 points labeled start and stop, okay, I might, if this thin red line notates the path that someone actually walked, all right, let's say that you're going from one class to another. You come down, you see one of your friends in the mall, then maybe over at the other side of the mall, you see someone else and you walk over to talk to them, and then you end up in a different part of the building, right? So this thin red line is showing us the distance that we walk. We would be able to measure this whole length here, and we would notate that as our distance. This green line, this darker green line, is showing us our displacement. It's a straight line. It just takes account where did we start, where did we end, and what is the difference in between. We'll start in physics here generally by analyzing scalars before we'll analyze vectors. It's just a little bit of an easier transition. And the first 3 that we'll use are time, distance, and speed. Time being defined as how long it takes an object to go through that course of motion, and the units that we're going to use there are seconds. Distance is going to be the length an object travels through that course of motion, and the units we're going to use are meters. This one's a little bit tricky because we're used to using things like feet, yards, and miles, but you'll see as we do more and more math and annotate more of these problems, the metric system is just much more simple. And then speed is going to be the rate at which the distance changes over time. And the units we use there are meters per second. And we can see almost in the definition of speed that we arrive at our first equation. Speed equals distance over time. And this is really bringing us to our first set of problems and how we're going to analyze different situations. And just like in math, we can solve a problem with one unknown. So generally, we're going to find situations where we have either speed and distance, distance and time, or time and speed. And I've noted there's another screencast specifically going over some examples of those problems and that's attached on Schoology. Any questions, shoot them to me on Schoology, and I'll catch you guys in the next one.